Welcome once again to my YouTube channel. So today we are going to continue with question on projectile. We have a question on the board. It reads, a stone is projected upwards at an angle of 30 degrees to the horizontal from the top of a tower of height 100 meters, and it hits the ground at a point Q. If the initial velocity of projection is 100 meters per second, calculate maximum height of the stone above the ground. Time it takes to reach this height. Time of light, and IV, horizontal distance from the foot of the tower to the point Q. So we have to make a sketch of this very question in order to help us solve it simply. So it says, a stone is projected upwards at an angle of 30 to the horizontal. Now let's say we have the horizontal level here. It was projected at an angle of 30 degrees. Okay? So it was projected at an angle of 30 degrees. From the top of a tower of height, the height of the tower is 100 meters. So this is the tower. The height of it is 100 meters. Okay? Then it hits the ground at a point Q. Now this tower is laid on a ground. Okay? So when this very body is projected, it follows this parabolic path and returns to the what? The horizontal level. So this is the ground itself. So that very point at which it hits is called Q. So with this, the very body gets to the maximum height, okay, before it now fall back to the what? To the ground. Now, the velocity of projection was 100 meters per second. So we have the velocity of projection to be what? 100 meters per second. So in order to solve the exercise, at least we have the diagram. We are asked to calculate the maximum height of the stone above the ground. Look at the highest height attained by the body. So above the ground, that means from here, we have to get what? The highest height attained. So here is the height from here now to this very point is the height of the building, which is what? 100 meters, right? But from here to here, we don't know the height. That is the maximum height, or we said the height at which the body attained before falling to the ground. So based on what we are asked to find the total height. That is h plus this. So if you do that, we are going to have total height. So at this point, the question we are looking for, which is the maximum height above the ground, h now becomes what? The 100 plus this h. So we need to get the value of this h. Now this is the maximum point it reached. So moving from this point to this very point, we consider the what? The maximum height, the very formula we are used to, which is maximum height is equal to u squared sine squared theta all over 2g. This is the formula for maximum height. So here we have h. Initial velocity was given as what? 100 meters per second. So we have 100 squared. Then sine squared theta is the same thing as what? Sine theta squared. So the theta here is what? 30 degrees. So we square it all over 2 times g. And the g here is what? 10. So we have the h equal to 100 squared will give us what? 10,000. Then sine 30 will give half. So half squared all over 2 times 10 is what? 20. So at this point, 0 will cancel out. 2 will cancel here. We have 500. So in this case, we have h. 500 times half squared. 1 squared will give 1. 2 squared will give 4. So at this point, the h becomes 500 times 1/4. That is 500 divided by 4. 500 divided by 4 will give what? 112. 125, right? Okay. So that is the highest height it can attain. But remember, that's the very first question they asked us, the maximum height of the stone above the ground. Okay, we have got this very h. Then what will now be the maximum height? If you do the substitution here now, we said the maximum height now will be what? 100 plus what? Plus h, right? Which is 125 meters. So the maximum height automatically becomes what? 225. So the maximum height is 225 meters. Now let's get to the question number 2. They said, find the what? The time it takes to reach this very height. Now, what's the time taken to cover this height, as in to reach this very height? Remember, the body was projected from this very level. It attained a particular height. So we are now looking for what? The time taken to reach the maximum. So second one, time taken to reach the maximum, we have a formula for it, which is this. So at this very point, the time becomes initial velocity, which is what? 100. Then sine theta, our theta is 30, divided by g, which is 10. Cancel this 0. We have t. 100 sine 30. Then sine 30 is what? 0.5. So we have t. 10 times 0.5 is the same as half. So we have the time taken to reach the maximum. 10 times half will give us 5 seconds. So that's the time taken to reach the maximum. Then the next question, we are asked to find the time of flight. So the time of flight, t, will now be the time taken to reach the maximum, plus the time of which the body took to return to this very level. So we take it as time taken to ascend, or the time taken to ascend that very point, plus time taken to fall from that very level. So we've got the ascending time, which is 5 seconds, right? Now let's get the time it takes to fall from that very height. Now, time it takes to fall from that very height. Now, on falling from a height, we have initial velocity there to be 0. Then it falls covering a height of 250, that is 125 plus 100, 225 meters. So the height there is what? 225 meters. Then you remember the acceleration is still acceleration due to gravity, right? And it's falling from a height, so it should be what? Positive. Now, to find this very time, from equations of linear motion, we have T, U, S, and the A. Then the one we don't have here is what? V. Checking from the formula, the one that do not have what? V. That should be what? Equation number 2. So we have this very equation, S equal to UT plus half AT squared, right? So here we have the vertical height. We have U. Then initial velocity here is 0. So we are working with this now. So at this point, h is 225. Half of g is 10. Then t squared, right? So half of 10 will give us what? 5. So I have 225 equal to t squared. So divide both sides now by 5. This will cancel out. So we have t squared equal to, if you divide 225 by 5, it gives 45, right? Then take root of both sides. We get the value of time. So square root of 45, it gives 6.71 seconds. So in that case, what will be the total time, which is the time of flight? So we have the time of flight, t, equal to ascending time is what? 5 seconds. Then descending time is what? 6.71. So the time of flight becomes, add both of them, it gives 11.71 seconds. Now we've got the time of flight, which is the total time is spent in air. Then the last but not the least, we are asked to calculate the horizontal distance. So to get this very horizontal distance, that's the last exercise there. That's question number 4. So the horizontal distance is the product of what? Velocity times time, right? So the horizontal distance, velocity times time. So in that case, the horizontal distance is u cos theta. Then times the time taken to reach this very point. It should be what? Time of light. So the horizontal distance, now we have u, which is 100. Then cosine of that very angle, which is cos 30. Then we've got the very time, which is 11.71. So the horizontal distance, if you simplify this, we have 100 cos 30. 100 cos 30 will give 86.60. Then times it by 11.71. Then we have the horizontal distance as 1014.12 meter. And that gives the final answer. So if what we did was able to help someone out there, please do subscribe, share, and turn on notification for others to learn as well. See you on our next class.